6.4 functions in vertex form. When we do these functions, we are dealing with either x squared, x cubed, x, or even the same thing as square root of x or cube root of x. So we're using the same rules that we did with the square root of x function and the cube root of x function. So any change that happens out front or outside of those parentheses, remember, it is a vertical change up and down. If it's inside the parentheses, it's opposite of what you would think and horizontal. So if we look at example A, we're stating the transformations here. So we have f of x is equal to 1/3 x cubed plus 7. First, start with that 1/3. The 1/3, there is no parentheses here, so that's vertical. It's a number that's smaller than 1. So that's going to be a vertical compression by a factor of 1/3. So vertical compression by a factor of 1/3. That x cubed, nothing is different with that, so we're just going to keep that. Don't worry about that because that x cubed is actually the parent function, which means it hasn't changed yet if it's only the x cubed. Now that plus 7 that comes after it, again, there's no parentheses there, so that change is happening vertically. So it's plus 7, so it's going up 7 units. For example, B, we have g of x is equal to negative 2x minus 1. So again, that negative is our first transformation there. So that negative means that it is a reflection over an x-axis, because when you reflect over an x-axis, you are moving vertically. So we are reflecting first across the x-axis. Then we have that 2 in front of the x. So that 2 that's in front of the x, again, there's no parentheses, so that number is larger than 1. There's going to be a vertical stretch now. Oops. By a factor of 2. And then that minus 1, again, no parentheses, so we're going down 1 unit. For C, we have y is equal to parentheses negative x minus 5, close parentheses, raised to the second power plus 3. So we are now dealing with parentheses here. So anything that's happening underneath those parentheses is happening inside the parentheses. It's happening horizontally, so side to side. So if we look at the negative that's in front of the x there, that negative is happening horizontally. So if you're reflecting horizontally, you're crossing the y-axis. So this is going to be a reflection across the y-axis. Then the minus 5 underneath, we're going opposite of what we think. So this is going to the right 5 units. And then that plus 3 is on the outside after the parentheses, so that means that we're going up 3 units. For D, we have f of x is equal to the square root of x plus 6 minus 10. So that x plus 6 is under the radical. It's just like it would be under or inside parentheses. So this plus 6 means that we're going to go left 6 units. And then that minus 10 is just down 10 units. For example, E, we have y is equal to negative 5 times x plus 4 squared. Start with the negative. That negative in front of the 5, it's outside the parentheses, so we're reflecting vertically. So if we're reflecting vertically, we're crossing the x-axis. So that's reflection across the x-axis. Then that 5 in front of the parentheses means that we are getting bigger because it's larger than 1. So this is going to be a vertical stretch by a factor of 5. And then that plus 4 under the parentheses means we're going left 4 units. For example, F, we have f of x is equal to negative 4 times the negative 1/2 x cubed. So we have a reflection first across the which axis? If it's going up or down, it's the x-axis, so reflect across the x-axis. Then that 4 is a vertical stretch by a factor of 4. And then the negative that's in front of the 1/2 means that we're going to do a what reflection? If it's inside parentheses, horizontal, so side to side, so that's reflecting across the y-axis. And then lastly, that 1/2 underneath the radical. It's underneath the radical, or inside the parentheses, I'm sorry. It's inside the parentheses, so we're going to do opposite. So take the reciprocal of 1/2, that's 2. 2 is larger than 1, so that's going to be a horizontal stretch by a factor of 2. So next part of this lesson goes into us being given the transformations with the parent function or with a function and applying those transformations to that function that we're given. So for example, 2a, we're starting with f of x is equal to 2x plus 3, and we have a vertical translation 4 units up. So with this, we're just going to be adding 4 to this and renaming this as g of x. So g of x is equal to the 2x plus 3, and then that plus 4, we're just going to add to the 3 because the 3 is already a vertical translation. So then this is just going to be g of x is equal to 2x plus 7. Remember, if there's any horizontal transformations happening, they'll be in parentheses or underneath a radical. For b, we have f of x is equal to 2x plus 2, and we have a reflection across the x-axis. Reflection across the x-axis is outside parentheses, so it's just going to go in front of this negative 2x plus 2. So we are going to have f of x is equal to a negative times 2x plus 2, because again, it's outside. So that negative is going to go outside of the 2x plus 2, so you're going to have to put parentheses in around the 2x plus 2. Oh, and this is g of x, not f of x, I'm sorry. So g of x, there we go. For f of x is equal to 3x plus 1, we're going 2 units to the right. So this 3x plus 1, we're going to have g of x is equal to, we have 3, we have x, we have a plus, we have a 1. Now this 2 units to the right is going to be minus 2 from the x, so we're going to have to put that in parentheses with the x. Okay, so we're going to have g of x is equal to 3 times x minus 2 is being added to 1, or having 1 added to it. You have to remember with this one, the transformations that are happening to begin with, the 3 in front of the x means a vertical stretch. The plus 1 means that it's going up 1. So in order to put in a 2 units to the right, it's going to have to be in parentheses. The only thing that goes in the parentheses with that is the x, which is why we separate that 3 from the x minus 2. For example, D, we have f of x is equal to x plus 2, and we have a reflection across the x-axis. Again, reflection across the x-axis is vertical, so it's going to be outside the parentheses. So we're going to have g of x is equal to a negative times x plus 2. Now, do you need the parentheses with this one? No, because the plus 2 is a transformation up or down. So if we look back at this one, this example B, we are actually going to get rid of these parentheses because we don't necessarily need them. So we can just have a negative 2x plus 2, because that plus 2 still represents that it's going up 2 units. So we're good. If you put it underneath underneath the parentheses with that one, it would mean that it was going left 2, and that's not what we want to put down or whatever. So at our next examples, we are dealing with stretches and compressions. So we're doing the same thing, except now we have stretches and compressions with these. So remember, if it's horizontal, it goes inside. If it's vertical, it goes outside. Remember, if it's horizontal, you take the reciprocal of the factor. So if we look at example A, we're starting with f of x is equal to 2x minus 1. So we have a vertical stretch of 2 units, and then it's going down 1 unit. Now we're adding a horizontal compression by a factor of 1/3. So this 1/3 is going to turn into a 3, and we're going to put that in front of the x inside parentheses. So this is going to be g of x is equal to 2 times 3x minus 1. For B, we're starting with f of x is equal to 3x plus 2. So we have a vertical stretch of 3, and then the plus 2 means that we're going up 2 units. And we're adding in a vertical compression by a factor of 1/4. So this 3 is going to be multiplied by the 1/4. So we're going to have g of x is equal to 3 times 1/4 x plus 2. So we want to multiply the 3 and the 1/4 to give us g of x is equal to 3/4 x plus 2. For C, we have f of x is equal to 1/3 x minus 2. So we have a vertical compression by a factor of 1/3 and then down 2 units. So now we're going to add on to this a vertical stretch by a factor of 3. So this 3 is going to be multiplied with the 1/3. So we're going to have g of x is equal to 3 times 1/3 x minus 2, or 1/3 times 3, same thing. From here, you're going to multiply these two. It's just going to become 1. So we're going to have g of x is equal to x minus 2. You have to remember with these, you want to try to state the transformations that are starting or that you're beginning with, because you're not trying to change anything with those unless it's the same type of transformation that's happening that's being given to you to add to it. So if we look at example D, we have f of x is equal to negative 2x plus 5. The negative means that we're reflecting across the y-axis, or sorry, not the y-axis, the x-axis. Then the 2 means that we have a vertical stretch by a factor of 2. The 5 means that we're going up 5. So now we're adding a horizontal stretch by a factor of 4/3. A horizontal stretch means that we're taking the reciprocal of the 4/3. So this is going to turn into 3/4. And then we're going to put that with the x around parentheses. So we're going to have g of x is equal to negative 2 times 3/4 x plus 5. And then the 3/4 x is going to be in parentheses, so that way we can determine that that is a horizontal stretch. For example 4, we are combining transformations now. So we're given the parent function of f of x, and then we're told that it's going to go down 2 units, followed by a vertical stretch by a factor of 5. So we're going to start with f of x is equal to x. It's going down 2 units, so this means that it's going to be x minus 2. No parentheses yet. So from there, it's followed by a vertical stretch by a factor of 5. So that we just put in front of the x to give us 5x minus 2. And then we put that equal to g of x to name the new parent function, the new function, and it's just going to be g of x is equal to 5x minus 2. For B, we have f of x is equal to x as the parent function. We have a vertical compression by a factor of 1/2. So a vertical compression by the factor of 1/2 is just going to be 1/2 x. Then we have a horizontal shift 8 units to the left. So 8 units to the left means that we're going inside parentheses, and we're going to be adding the 8. So we're going to put parentheses around the x plus 8 and then close them off. So g of x is equal to 1/2 times x plus 8. For C, we have f of x is equal to x as the parent function. We have a vertical compression by a factor of 2/3, followed by a vertical shift 6 units down. So we're going to start with that vertical compression. Vertical compression is outside, stays the same, so that's just going to be 2/3 times x. Then we have a vertical shift by a factor, vertical shift 6 units down, so that's just going to be minus 6. So our new function is going to be g of x is equal to 2/3 x minus 6. For D, we have f of x is equal to x as our parent function. We're going to start with the x. We have a horizontal shift 4 units to the right. So that's going to be minus 4 inside parentheses with that x, followed by a horizontal stretch by a factor of 3/2. So we're going to take the reciprocal of that. That's 2/3. And we're going to put that 2/3 inside the parentheses. So we're going to have g of x is equal to parentheses 2/3 x minus 4. And then we're done.